So this says listed below are the measured amounts of lead in the air. And it says the EPA has established an air quality standard for lead of this 1.5 micrograms per cubic meter. And it says use these values to construct a 95% confidence interval estimate of the mean amount of lead in the air. So the first thing I can see is I'm going to go to my formula sheet, and it says once again to construct a 95% confidence about the mean. So I know then it's going to be something in here because this would be a confidence interval about the mean. They did not give me a standard deviation, so I have to find that. So that says I'm going to use the t-table. So I'm going to end up using this one here. All right, so that's going to be my formula that I'm going to need. So as you can see, I need the mean of that data set. I need the standard deviation, and then of course the sample size and this t alpha over 2 value. So let's just go ahead and first, I guess let's go back here and find this t value. So you find the t value, you go to the t-table, if I can find it. So there's the z, here's the t-table. And what you do is you count the number of values. So there's 1, 2, 3, 4, 5, 6, and you do one less. So your degrees of freedom is one less. So the degrees of freedom would be 5, okay, because there were 6 of them here. And then I'm going to look at a 95% confidence, which is going to say for 95%, then the error in the 2 tails would be 5%. So if I look for degrees of freedom at 5 and I go straight across, I get 2.571. So write that number down, 2.571. All right, so then from here, what I'm going to do is, let's just, if I can find it, my whiteboard, I'm going to go ahead and write down what I'm doing, and then I'm going to grab the calculator and use the calculator to figure everything for me. So I want this, my mean around the error, and I know my error equals this t alpha over 2 standard deviation divided by the square root of sample size. We just found this is based on a 95% confidence. We got 0.571. So I need to find the mean and I need to find the standard deviation. I already know that's my sample size, which is 6. So going back here to my data, and let me find my nice little lovely calculator. So first thing I need to do is get this data in my calculator. So if you remember, we do that by pressing Stat, Edit, Edit. And unfortunately on the computer I have to type each one of these in. So, and you have to do this on your calculator. It's just kind of a pain because I have to push the buttons. 0.45, 0.75, 0.67, and 1.3. So that's just all my data values in there. So 5.4, 1.1, 0.45, 0.75, 0.67, 1.3. I'm going to do second quit just to close that. And then here is where you do the second vars. No, you don't. You do the, sorry, I didn't mean to do that one. You do the stat button. Okay, so I press stat. You move over to calc, and this is one variable statistics. If you remember, we did this back in the beginning of the class. It's just, it's been a while. And so the one variable stats gives me, based off of my list, so second L1, it gives me my mean, which is 1.612, and it gives me my standard deviation of 1.88. So I don't have to go do the trouble to manually find these. All right. So then going back to my, where I'm writing this stuff out here, well, let's just move this stuff around a little bit. Then I know from here I can just start plugging everything in. So again, my mean is 1.612 minus my error 2.571 times my standard deviation 1.88 divided by the square root of 6. So that will be my lower, and then the upper will look just like it except you add. So 0.571, 1.88 over the square root of 6. And for this one, I get negative 0.361 because it says to round to 3 decimal places. And for this one, I get 3.585. All right, and as you can see, that's definitely my answers over here. And then it says, is there anything that suggests this confidence interval may not be good? Well, the big thing to notice in your data is it seems like that first value is really large, so that would be an outlier.